Right, so Andrea's going to give us the first talk of the evening about biohash.
Yeah.
Right.
Okay, thank you, Marius. Okay, so today I'm going to tell you a bit about how you can bridge the gap between computer science and other sciences. So first of all, a little bit about me. Hi everyone, I'm Andrea. This is the gift of me studying. I'm studying computer science at the University of Edinburgh, and I will tell you how I spent my summer doing research in synthetic biology, which is unusual for a computer scientist, and how I found out that I really, really love science. A lot. So I did this project in synthetic biology without knowing anything about biology. So when I started this project, I was really, really scared. And to make it all worse, they had me go in the lab on the very first day. I was totally wrecked. I had no idea what to do. They handed me a pipette, and it was like, okay, so you have to do this transformation. Okay. Somehow it worked out. I had really good guidance, and it really worked out. And I found out that it's amazing, and I loved it. I could actually do something and then see the results of my work. So that was amazing. And yeah, this is me running it down. That's how far I went. This is my first bacterial colony. Isn't it really pretty? And this is being really responsible in the lab, and I got told off for this. But I still like the lecture. Apart from this, it was a really good project, but something came to my attention. Is that scientists are selfish, and not in a really bad way. It's just that since I knew nothing about biology, I needed my biology teammates to explain even the most basic concepts to me. Well, they were quite useless, because they didn't understand that I didn't have any biological background. So they were basically explaining biology with biological analogies. I could not understand any of that. And yet it worked out, but it's just such a shame because it doesn't happen only in my team. It happens everywhere. Scientists just assume their work will be proofread or reviewed by people who understand it. And that makes it inaccessible to the general public. Let me tell you about my project. We're basically building a biosensor that will test the purity of drugs. It's just a strip of paper that you dip in a substance and then changes color according to purity. It's all nice and sweet, but if you think about the user, how is the average drug user going to notice the difference between this shade of blue and this shade of blue? They are different, I swear. Well, it's simple. We make an app for it. We built an app that would allow the user to take a picture of the strip, and then analyzing it and comparing it to a color shadow we put together in advance. It would just look nice and clear, a simple response on their smartphone screens. So isn't it just so simple? It was so easy to make science accessible in our project, so we thought, why not do it at a larger scale? And that's how the idea of a biohack came about. Still, why is it a really good idea for a biohack? Well, it's interdisciplinary, and I'm a firm believer in this. A while ago, people used to tell me that if you know one thing and you know it really well, it's enough. I don't really agree to this. I really believe that you should try a little bit of everything until you find a combination that perfectly suits you. It's so sad that so many people don't realize it yet. While I was advertising this event, so many people just seemed so reluctant to it. They were so not willing to step out of their comfort zone. Computer scientists were like, I don't know anything about biology, why should I come? Biologists were like, I can't code, there's no point in me coming. Well, that's okay. Hackathons are not about winning something. Hackathons are about learning something new. They're about experimenting with new technologies and sharing knowledge with like-minded people in a relaxed environment. The main aim of a hackathon is to contribute to their personal growth and, of course, to have fun. And I don't just mean blowing up stuff as well. So yeah, we went ahead. It's really fun. We went ahead and made this a thing, and we call it a biohack because it was biology and computer science and hackathon. So yeah, let me tell you how it went. So on the day, we had to wake up early. For me, this was particularly hard because my day starts when my flatmates are having lunch. Then I had to hope that people turn up. As I was saying, no one seemed really, really excited about it. So it was touch and go. Also, it was during the Fringe, and they could have always chosen a random show instead of my hackathon. Then, as a typical typical organizer, I spend so much time worrying about the food. Will the pizza arrive on time? The hackers, are they happy? Do they know what to do? Do they like the idea? Again, the food. What if someone has some allergies and I forgot about them? The sponsors, are people using their APIs? Do they feel that it was a good investment? The Wi-Fi, is it painfully slow? The swag, did everyone get enough laughter stickers? Again, the food. Like really, I was really worried I wrote the wrong address on the order and it would never get there. So yeah, I had a lot in my mind, but when I finally found out, it was all okay. We got the food. But apart from the really important part of the hackathon, I figured out that while I was talking to hackers, I was around some amazingly talented people. All of them were there because they were truly passionate about science, and they showed off this passion with some really great projects. We had some nice biosecurity ideas. One of the teams built a face recognition app that would allow you to access your data after placing your face in front of a webcam. Then we had other teams discussing DNA identification that could be used by JP Morgan, one of our sponsors, for their security apps. We also had a Tinder-like app because there's no hackathon without one. Only this one would match you with people with compatible personalities. The people would spend a lot of time working out which gene influences which personality trait, and if that got them in the first place. Then we also had some people trying to incorporate hardware in their biological-related hacks. Someone tried to help dementia patients by using a Pebble watch to track their movements during the night and send a text when strange behavior was detected. Then we had someone who tried to monitor the workplace satisfaction using the news headband and placing estimates around the office. So that would allow you to map the feelings that someone is feeling in a certain part of the office. So yeah, I met some amazingly talented people. I can't stress this enough. And I don't think there was a better way I could have spent my Sunday with. And at the end of it all, I was like this. But when I finally woke up, all I wanted was to do it all over again. And we will do it again, but only this time, not for just biology, but all sciences. Not for 12 hours, but 24 hours. And I hope this got you all excited about it, and you'll come along to it, or even help me organize it if you want. Thank you.
Question?
Yeah?
What is the definition of life?
Sorry?
Life.
Protein, no. DNA turns into protein, DNA turns into RNA, which turns into protein. That's it.
But what about time cycles?
And it takes about, you leave them overnight, and then it's fine. That's how everything works in biology. Like, you do it during the day, come back next day, see if it worked. Most of the time it doesn't, but so you have to do it all over again.
Cool.
Okay.
Other question? No?
Alright,
Well,
thank you.
thanks, Andrea. We're gonna take another 15-minute break. I'll take this chance to thank our sponsors again, Skyscanner, Informatics Ventures, and Cultivate. So yeah, 15-minute break, toilet break, whatever. Talk amongst yourselves. Yeah, see you in 15 minutes.
About nutrition tracking app for like quantifying self-data. It's on the
This is rubbish. It's a bit of a problem. Certainly that would be the goal for us. Yeah, I know it's down the shirt.
Have your text with me, but we haven't precise. There's an ambiguity in this text message, so I told I think I have no time to go, so I will restart this one. Start text. I hope you enjoy. Regards to this, I hope to see But yeah, that's the ambiguity. Unless the crease is tight, Girls no. Regards from Javier, regards from Javier. Regards from Javier, our crease is Use my
The audio pick Andrea.
Of course, better quality acoustic microphone there, cables, something like that. So I also asked them could be always better quality because I'm using one headshot, and the second one
So when people speak when they reference refugees, because it's quite so could be better.
I'm sure. I seem to recall previous months there were nights kind of
I mean, I have a mic. It's not a problem.
Yeah.
What I need only getting the connect to the
Yeah, so
The worst it could be, I would say, bit sad about
Right, everyone, can I get your attention, please? If you could have a seat, we're going to start the second talk of the evening. Right, so next up, we're going to have Matt talk to us about building an app for quantified health.
Hello, good evening everybody. So, first of all, a quick synopsis about what I'm going to be talking about. Briefly about quantified health, I'll explain that in a second. A bit about the context of how we, Encros as a company, operate, and then on to the meat of the talk, which will be our experiences and the build process that we've been using for building an iOS app. So first of all, who am I? I've spent up till recently 15 years as the technical director of a web development agency down in Bristol. I've just come up here today to see you guys, meet up with some colleagues, and also go to some of the other networking events up here. Although I live in Bristol, I guess I can trace my roots to about 40 miles west of here, back in the 1600s, when two Norman soldiers turned up, joined, well, they turned and joined Robert the Bruce, and they were told they could stay at Casdo Castle, and only for the duration of one crop. So they planted oak trees. And that was the start of the Hamilton clan. They were there at Hambledon and became what became Hamilton. So I have got some Scottish roots in there. I'm a Python developer. I'm now thrust into the world of mobile, which was a very interesting transition, moving from one to the other. And I'm the lead of the Enquos mobile team. So first of all, what is quantified self? The quantified self is a movement to incorporate technology into data acquisition and aspects of a person's daily life. So this is taking nutrition, fitness information, things like blood pressure, mood, that sort of thing, bringing it together to try and give people a better understanding of how their body works, better achieve the outcomes they want to achieve. Now, those outcomes can be based on all manner of things. It could be that somebody is an athlete and wants to increase their performance within a sport. They could be trying to manage a chronic illness or something like diabetes. They could be looking to lose weight. They could be I'm just curious about what's going on, you know, or I want to lower my cholesterol level or whatever it might be. Now, there's a number of things out there that people have come across. There's the things like the fitness trackers. There's things like the Fitbits that people, you know, have on their wrists. Things like cycle computers, connected blood pressure monitors, glucose monitors, Wi-Fi enabled bathroom scales, and there's apps, things like MyFitnessPal that most people will have heard of, Strava and Runkeeper for people cycling and running. But there's no one place to kind of bring this all together. And that's really what Enquos is about. So Enquos is the first comprehensive system to tie together and the tracking of food and activity with these outcomes. So it was founded by our CEO, a woman called Anissa Shaheen, in Los Angeles a few years ago, and based on her personal experiences with the kind of early first generations of connected health and tracking and things like that. You end up with data silos, different devices recording the data and putting it online in different places. But you really want to see, okay, well, how is my nutrition affecting my physical activity, or my physical activity affecting my nutrition, or my sleep, or my blood cell count, or whatever it might be. And that's what Enquos is looking to try and solve. So we're a team of over 35 people spread across 6 countries, 11 cities. We're sort of fairly well spread out. Rough few shots of some of the people working from Serbia right the way across through Italy, Germany, the UK, Scotland, up here as well, through to both the east and west coast of the US. And in terms of the architecture, we've got a web-based system. We've got the mobile apps, which is what I'm going to be talking about today and what we're building, and we've got external sources. So unlike some systems, we're not just mobile, you know, a mobile app and that's it. We have actually quite a large comprehensive web system as well. And so that web system allows you to do a lot of analytics on your data. So you can start picking arbitrary metrics and start graphing them against each other and seeing how you're doing. This is the kind of stuff that we can do at the moment on the website. You can track things like supplements and vitamins. So if you're taking a particular supplement, be it a prescribed medical supplement or a more holistic natural supplement, then you can track those as well. And we integrate in with the data sources, like I said, other apps and devices. The back-end stuff is all written in Python and uses the Pyramid Web Framework. We use Cassandra as a data store, which is a distributed object database, or rather non-schema. I don't know how you best describe it, schemaless database. But we've got a very strong focus on testing, and so our test infrastructure, this is just that you can't really read this, but the bit at the top, each one of those graphs at the top is for a processor. Our test infrastructure has 128 CPU threads, half a terabyte of RAM across 4 servers, and the test suite is broken down into about 60 segments. And at any one time, there'll be between about 10 and 16 Docker instances on each server running a piece of the test suite. It takes about 20 minutes to run a full test run of our web app. And it goes through and and it goes through both unit tests but also automated tests. So we use a system called Robot Test Framework, which came, I think, mainly from Python world and from the Clone content management system world, to do automated browser testing. So this is all being driven. This is a screen capture, but this is being driven. The tests are in the terminal on the left, and the browser is being completely automated and driven. Now, I wanted to try and bring this methodology over to what we were doing with the iOS apps. Originally, we didn't have a very strong testing culture with the mobile side. The mobile app was originally developed by a third party, and their testing culture was not as strong as ours, and I wanted to try and bring that in. So the iOS app is the main bit I want to be talking about this evening. Who here's done any mobile mobile app development? Put their hands up. So, okay, about a quarter of the people in the room. The build process for building, especially Android's easier, but iOS, the build process is long, it's arcane, it is generally not that well understood by even the developers themselves. They use the Xcode IDE, and if something goes wrong, there's a big button that says fix it, which if you hit enough times will eventually do something and work. But it's a bit mystical. And the actual build process is, it doesn't work with a distributed team. So if I develop an app on my laptop, I can plug my phone into it, and I can deploy that app to my phone. That's not a problem. It is signed with my personal developer certificate that I get given by Apple when I sign up for Apple's developer program. If I want to build it to give to somebody else to put on their phone, then I have to go through a third-party service, and the app has to be signed by a different certificate. Now, I have to have the keys to that and the certificate that go together in order to sign that. Okay, so that's fine, so I get those. Now, if another developer on the team wants to do that same thing, they need the keys. Now, these are the magic keys to our kingdom, right? These are the keys that control what ends up on the iTunes App Store at the end of the day. So it's a bit of a security headache, because you don't want to be just giving these out to every developer. I trust our developers, they're fantastic people, but it becomes a bit of a nightmare. And different builds have different parameters. So if you want to build a build for debugging, then you'll have various debugging flags turned on, crash reporting, so when a crash happens on a device, it reports it back in a certain way, various bits and pieces. You'll have a staging API possibly you work against versus the production API, you'll have test data. So it becomes a bit of a nightmare. So we've automated it to the best we can at the moment. We use a number of tools. GitHub for our source code repository, most people will be familiar with. Fastlane, and the three in the middle I'm going to talk about in detail. So Fastlane is the tool we use for automating the build process. Jenkins is the tool we use for coordinating and firing off the actual build processes. Hockey and TestFlight are two third-party services we use to actually distribute the apps to the build. And Slack is our communications medium. Slack is, for old school, is IRC on steroids, or IRC with a nice pretty face. It's our chat system within the company. So Fastlane was built by a guy called Felix Krauss originally, and it helps automate the builds. It allows you to have multiple lanes. So you could say this is the development lane, this is the beta test lane, this is the production release lane, and certain steps can happen. And so you can automate what goes on within them. And that enables you to have repeatable, scriptable builds. It also gives you an API for iTunes Connect, which doesn't really have a way of accessing it in an automated way. So there's a lot of things you have to do. If you update an app, you've got to take a bunch of screenshots of the app to put on the iTunes Store. Well, we support 4 different devices in our app: iPhone 5, iPhone 6, iPhone 4S, the old one, iPhone 6 Plus. That's 4 different screen sizes. That's not counting iPads and the like that we're not explicitly supporting at the moment. Now we've got to take 5 screenshots to go on there. So that's 20 screenshots we need to take and upload. Now potentially we need to do that for each language we support as well. So as you can see, this very quickly becomes quite a chore. So Fastlane helps automate some of that, which is great. So the way works. I'm going to go into, I'm hoping the audience here is, from what I've gathered from previous things, reasonably technical. So, but this is the kind of, it's a Ruby-esque language. Well, it is Ruby. I personally, yeah. I don't get it. Ruby allows you to create languages that look like Ruby. So it confused the hell out of me when I started using it because I'm not a Ruby programmer, and Ruby just feels like a language where somebody's removed half of the verbs and just doesn't quite make sense to me. I will wrap my typing brain around it one day. But, so this is the build method that we've got here that does the actual build. So there's a number of steps. So first of all, we increment the build number. Every time you have a build, it has a build number associated with it. It also has a sort of a marketing version number. So that's, you know, marketing version number will be like 1.2 or 2.0. The build number will be 632 or whatever, and is incremented. So we increment that, and actually we take it from an environment variable that gets given to us by Jenkins when we run it. So it's actually the job number in Jenkins when Jenkins runs it. We update a bunch of information about the app, depending on whether it's a release or whether it's an actual, whether it's an alpha branch there. So each app has an identifier on the phone, and this is a unique identifier for each app. And so it's com.enquotes.nutrition is the identifier for our app. Now, you couldn't have multiple builds with the same ID. They would just overwrite each other. So what we actually do, if it's an alpha, the else block at the bottom, we actually call it com.enquotes.nutrition.alpha plus an ID based upon the branch from Git, and I'll show you a bit that later what that does. Sign is the thing that deals with signing. Signing is a necessary evil, but a pain. And there's very wittily called tools called Sign by the developer. So it deals with actually signing the binary, or rather fetching the profiles needed to do the signing. Then we update a number of metadata files. So normally within Xcode, you click buttons and go into Windows and change stuff, and you will get various flags that you can set and bits and pieces you can set in there. We set these manually. So that means that the developers doing stuff in Xcode don't have to worry about it, whether it's an alpha build or a base build or whatever. This script will change whatever they've said it is into whatever we want it to be when it is built. So they don't have to worry about that. That updates the app identifier, the display name as well. So the display name is what's actually shown on the device. So we call it based upon, in the previous thing, we set the display name to be based on the Git branch as well. And then the final bit, IPA here actually builds the package. And it builds it based upon, there's a couple of things you can use to influence build, a thing called a scheme and a thing called a configuration within Xcode. So the scheme is whether or not it's a developed release or a sort of a final release. Configuration is a similar kind of thing as well that sets whether or not debugging is turned on and things like that. So that does the actual signing and building of the actual app itself. So that's building it. That set there builds the actual app. We then run some tests on the app. Now, the tests are run on a simulator. The simulator runs on a Mac Mini. The Mac Mini has an x86 processor in it. Your iPhone does not have an x86 processor in it. So the process is, fetches the stuff from GitHub, builds it for the simulator, x86 architecture, opens it up on the simulator, runs the test against it, then rebuilds it later on for the iPhone architectures, the ARM processors, and then uploads it. So there's several sort of steps that happen there. This is running the tests, and it runs a thing called XC test, which actually runs the tests. We set various parameters in here, what platform we want to run it on. So we're running these tests against an iPhone 6. I'm actually looping through two separate test suites at the top there, because we have two separate test suites that we want to run independently of each other with no shared state. So the difference between nutrition and nutrition app test, it has a completely fresh copy of the app started up, so there's no dependency between them. And we report it out in a format called JUnit, which is what Jenkins will then understand and display. So this is the part of the actual distribution then. So we've got two lanes. Sorry, I'll go back. On the left we've got the alpha lane, on the right we've got the release lane. Now it seems a bit of a jump to go from alpha to release with no sort of beta or release candidate. I'll explain that in a little bit. So the alpha lane, we call those two things I've just shown you. We run the tests and we build the app. Although it's an alpha lane, we call it beta, historical reasons. We then upload it to Hockey. So Hockey is I'll talk about it again in a bit, is a third-party service for distributing the apps. But the reason we're uploading it to Hockey in this case is we're using it to collect crash reports. So if the app crashes, when the user starts it up again, if they've opted in, it will send the traceback up to us so that we can see it. So as soon as it crashes, we can get it, which is, you know, if it's on a device in somebody's pocket, the other side of the world, that makes it easier for us to start debugging things. So Hockey's really good at that because it actually groups the crashes together into crash groups. So if it's the same crash that's happening every time, it will group it together and show it to you and say, okay, there's been 23 crashes of this type. Not only that, it opens a ticket for us in Pivotal, our issue tracker, and reports it to Slack so we know about it. So that's really cool. Then it reports it to Slack. So it then reports that there's a new alpha build done, and we can then, it has the build ID, some metadata there, and it also has the download URL. So you'll see this in a minute. So we've run the test, we've done the build, we've uploaded it to Hockey so that people can download it, we can get crash tests, and we've announced it on Slack. The release side, we do a similar thing. Pretty much everything's the same, apart from this line here, deliver, where we actually deliver it to Apple instead. So we do send it to Hockey, but we don't actually allow people to download it from Hockey. We send it to Apple's distribution service called TestFlight, and by marking as a beta, that means it's available there for beta testing directly from Apple. And I'll talk about Hockey and TestFlight in a minute. Jenkins, so Jenkins monitors GitHub and builds a new app when it sees a change. And we've got separate jobs for the develop branch. So we use a system called GitFlow, which is a defined set of naming conventions for branches and the way in which you work with stuff. So we have the master branch that the main releases are made from. We have the developed branch, which is where the development happens. But each feature that's built is built on a feature branch that comes off the develop. So we'll have a feature branch named a hydration UI, and that will be the branch that is working on, that the developer's working on for building the UI for logging your water consumption. And that then gets merged into develop. So that's the UI hydration branch, or what's called a feature branch. So you've got separate jobs to develop, feature, and then finally the app store itself. So Jenkins, if you've not seen it before, looks like this. It's a continuous integration and testing system. Basically what it does is it continually builds things. As soon as a change happens on the source control, it notices it, builds it, and runs the tests. So as soon as somebody breaks something, you know about it. And it gives you some metrics as to how stable the build has been, what's been going on, etc. You can see the three jobs I mentioned: develop, feature branches, and the store in the middle there. But it's just a system, in our case, for running these. Now, like I said, Jenkins is normally used for testing, for running tests. We're actually using it to actually build the app itself as well and distribute it. And it can keep track of tests, so it's just a graph of tests over time and how many tests are passing each time as we're running. So I mentioned these two services, TestFlight and Hockey, and they both do roughly the same thing. You can upload an app to them, and they allow you to distribute that app to people to test before it goes into the iTunes store. However, they're slightly different. Hockey allows you to have a much richer, has got a much richer API for controlling it remotely. It allows, when apps are uploaded to it, they're available immediately for download. Whereas if you upload to TestFlight, they do some processing and check various APIs and stuff like that and analyze it a bit. And it can appear half an hour later, it can appear 10 hours later. It's a little strange like that. I mentioned about having to sign apps. So there's two different, in this case there's Hockey uses what's called an ad hoc profile, and TestFlight uses what's called an app store profile. So the ad hoc profile is So with Apple, they want to control who has access to which apps on which devices. And the way they do it is by digital signatures. And what happens in an ad hoc profile is you actually have the devices listed in that profile. So everybody's device is a thing called the UDID, the Unique Developer Identity, I think it's called a device identity, is listed there. It's like a serial number for the device. And everybody who you want to be able to install on the phone has to have their UDID listed in that profile before the app is built. So it does mean that you have to make sure that the people who are going to test it you know about before the app is built. And it's not exactly the same binary that you would then go and release, because you would then do it differently, because you'd sign it with an App Store profile, which is when Apple go and review it, they take a week, they look through it, they review it, they say it's all okay. They then sign it with their key that says, okay, anybody who's got an iPhone can download this from the App Store and run it. But that process takes a lot longer. So we use Hockey for the what we call the alpha builds, and then TestFlight for what are becoming the release candidate builds and the release builds. Now the thing with TestFlight is because you can upload it to them and say, okay, this is a beta release. It means somebody can who's part of your beta program or beta program can download it and use it. But you can then submit it to Apple at any point and say, okay, this is the one I want in the App Store. So you're much closer to the final product that's going to go into the App Store, which is good. There's less chance of any kind of discrepancy between the builds. So this is just in Hockey. Now you probably can't read there necessarily on the screen, but each one of these listed here is a separate app. Now it's all our app, but they're all versions of our app, and each one has been named after the Git branch. So we have feature share meal social platform, feature hydration dashboard, feature week view integration. So each of these are what the developer is working on at the time. So what it means is we can have multiple developers working on different parts, different feature branches, and Jenkins, TestFlight, and then Hockey end up building and distributing an app based specifically on that branch they're working on. So this is before the code's been merged into the main branch. They could be working on something and people get to test it out much earlier. And so as an example of that, just showing here, so showing up on Slack on the left, there's a build there that Fastlane has announced. There's a build there, feature share meal social platform. There's a download URL. If you click on that on your phone, you end up on the right hand side, you end up on Hockey's site, and you can hit install and install that. So you can go ahead and install that. This is before it's been merged into the main branches. You can also, with Hockey, unlike TestFlight, with Hockey you can actually go back versions as well. So you can actually look at a previous build. So there's two builds. There's a build at the top there, 460, and below it 450. I could actually restore from 450 and say, actually no, let's go back and see there was a regression. I want to see what it was before. The downside of this is you can end up with lots of apps that look almost very identical because it gets the name truncated off the end. So if I was clever, I should have put the branch name first rather than last, or done something else. The trick is to tap on it to go to delete it, and it'll come up and say, do you really want to delete Enquo's nutrition feature / UI hydration log? And you go, no, that's the one I want to run. And you then tap on that. TestFlight, well, same sort of thing really, that's in TestFlight, and then we can invite external beta testers to it, and they get an email that says, hey, you've been asked to invited to test this, you can test it. So kind of a typical flow for us in terms of how things are developed. So just kind of showing you, I say we use Slack a lot, sort of all day, and everything's reported into there. So on the left-hand side, you can see a notification from GitHub that a new branch has been, or a new set of commits has been pushed to GitHub. It's under the branch feature / week view integration by one of our developers, Ben. It's got all the commit messages there. He's pushed that in. And then just a couple of minutes later, there's him on the right-hand side. It's just sequentially following. Just saying to our UX guy, Russ, I've pushed the change to the week view. So the date range part is much simpler, definitely looks cleaner. Hockey app should have an update soon if you want to see it. Russ is a very happy guy. I'm happy too. And then 6:57 down the bottom. So, well, 12 minutes after the push happened, Fastlane is telling us we've got a build there. So on the left-hand side, it's that full message there, Fastlane telling us we had a build. So that's only 12 minutes since the developer did the push, it's built it, tested it, uploaded it, it's ready for you to go and get it, which is just makes life so much easier when you're trying to test things, because the alternative is that you have to check out their version of the code, you have to build it locally, stop whatever you're doing, you know, check out their one, build it locally, then install it on your phone, and then test it out. Whereas this is much quicker. So I can then download it. Sorry, on the right-hand side, I had to play around with it, and I had some comment about how it was looking. I was able to take a screenshot directly on my phone and upload it using Slack's client directly to there to continue the conversation. So very, very rapid iterations on feedback, which is really good. So really, just to kind of finish off, just a quick sneak preview of the app as we're working on it. This is not public yet, but on the left-hand side, we've got the hydration view dashboard that shows you, it's like a radio, almost like a sundial showing you what's going on. And on the right-hand side, this is just a view of the sort of main logging screen and the nutrition view. So you can see that graph there back in time showing how your intake compares to your exercise. So if the line is going up and is red, you've eaten too much and not exercised enough. If it goes blue and goes down, then you've exercised more. And you can go in and log food against a particular meal in there as well. So in there was just a picture of spaghetti bolognese, but I can go in and search. And one of the great things is the search is all offline. So unlike some of the other apps that do this, this is all completely offline. Will work whilst you're on a beach or in a restaurant, or just in America where they don't seem to have much, mobile coverage. So you can go in and so that's that. So thank you very much.
Questions?
Yeah.
How long did it take you to put together the whole building process and everything?
Well, I started just under a year ago, and probably started putting it together when maybe about February time, March time. So in terms of elapsed time, it's basically been me that's been building it in that amount of time. I would say it would be a lot quicker if knowing what I know now, I was having to learn everything about iOS development at the same time as well. But I have actually been blogging a lot of this as well, for anybody else who wants to sort of follow up and do a similar sort of thing. But it would be fairly quick. If I was to sit down now and set it up for somebody, you're talking a couple of days, I think, to do it. Know what's going on.
I had a quick look on the website, and it's interesting. Is it paid, or how do you make money?
Yeah, it's paid. So there's a if you sign up on the website, you get a free, I think it's 30 days premium membership, and then it drops back to basic membership, which has some of the premium features disabled. But yes, it's a paid service. We don't advertise to you. We don't take your data and farm it off to somewhere else. Some other apps like this do send data off to third parties for various reasons, but we're very strong on privacy of data, so we don't send it anywhere. We get it, keep it.
Sorry, leads to another question. What about exporting data?
Exporting data, that's not there yet, but it is something that's definitely we are keen on doing now. Sorry, this gentleman's first.
There's lots of apps like this. What's your main differentiator?
So the main differentiator with us is there's a lot of systems that do this, but we are probably the most comprehensive across all sort of aspects of somebody's health and fitness and nutrition. So we can log things like, you can log your, the size of your biceps, you can take measurements of your biceps, or you can log the mood you were in when you were eating something. Was it a Was it an emotional hunger or that sort of thing? You know, you can sit down and say, well, yes, okay, well, I did eat that, you know, entire pot of Ben and Jerry's, but look at the emotional thing. I was, you know, I was distraught, and you can see I didn't sleep at all that night. And so that's probably the main differentiator is the comprehensive, but also our nutrition side is run by, we've got a registered dietitian that runs the nutrition side, and so all of the data in here has been checked by nutritionists, and we also have meal plans and things like that that have been designed by dietitians. So you could go on there and say, right, there's a balanced meal plan for weight loss or something, or a post-bariatric surgery weight plan, or a vegetarian weight plan, or whatever it is. And there's different plans in there with meals in. So,
can you import data from Strava, Fitbit?
yes, you can do. Fitbit, yes. Strava coming soon. Garmin, Withings, lot of at the moment. But yeah, Strava is coming soon, and Polo we're working on at the moment as well.
So how does that sort of work then within the app?
So that's nothing to do with the app. That's entirely done on the back end side. So you configure that on the web, and it fetches it, and then the data then comes from there down to the app.
Right.
So for instance, my activity data, when you saw the screen then, it showed how much activity I burned, actually came from, I've got the Moves app on my phone. The Moves app tracks how much walking and cycling and running, whatever I do. That sends that up to the back-end system, to Moves. The back-end system fetches it from Moves. It then comes from there down to the app.
Are there any big apps that you can't get in?
Probably. I hate to say, we're adding
What sort of coverage do you have?
more all the time. Have a look on the website. If you go on the website, there's a list there, especially if you log in, definitely there's one under settings. I think you can get to beforehand though. There's a devices and apps section.
Yeah, sorry, I'm interested partly in sort of, I guess, the business model really, I suppose. Because if I look at, say, Peso and MyFitness, I think it is, they're already integrated apps which are running, which cover a lot of this already, but they're effectively free. So I don't know how you're going to win over the customer.
That's a very good question. That's beyond my remit running the mobile team. But what I will say is that, yes, so for example, MyFitnessPal, they are owned by a company called Under Armour that makes sports clothing. And, you know, it wouldn't be too much of a stretch of an imagination to say that they're using some of the data to then, you know, work on that side of things. We don't process the data. So, but we are looking as well to working directly with healthcare professionals as well. So it might be that you work in conjunction with, say, a dietitian or whatever, who would also, you can share data on here as well with specific people. You can say, all right, I want to share this data with this person.
Yeah, I guess I was kind of curious if you're aiming for a specific demographic, you know, elite athletes, for example.
I would probably say the demographic is the people for which the likes of, say, MyFitnessPal are not enough. In whatever form that might be, either the accuracy, the speed, or the ease of use, or whatever it is they're trying to achieve in there. We're not trying to directly compete with them, I'd probably say.
One last question. Question for you.
I'm just wondering how many sort of versions of the app are you building each day?
So we had a 1 week sprint in Bristol, and we had the developers there, and I think there was something like 260 off the top of my head builds done in that week by the app. So I expected to go back and find it a molten mess on the floor. It's only a little Mac Mini.
And how does that relate to how many actually get released as a sort of end product, and how frequently that happens?
Well, this hasn't. What I've shown you in the sneak preview hasn't been released yet.
Oh.
So, but we're up to build numbers in the 400 or 500s, I think, at the moment. So, but like I said, it just continually builds the whole time. As soon as something happens, it builds. At any point in time, we could say, right, let's go, and that will be the one that's released. So at any point in time, we can just say, as soon as the code gets merged into master, it kicks off a build that ends up on test flight. And at any point in time, I can hit a button on test flight, and that goes to Apple for review, and that would end up in the App Store a week later. So we can deploy at any point in time.
I was going to say, would that be interrupted if the tests were failing in Jenkins? And
yes.
Yeah,
if the test failed in Jenkins, it aborts it. Yeah.
Well, I guess if you have questions,
yeah,
we're going to have Matt come to the pub with us.
Yeah,
thanks, Matt.
We're also looking for some more iOS and Android developer to join us.
So yeah, that concludes this month's Tech Meetup. If you can all join us at the pub, I think we're going to go to Pear Tree, just because it's nice. Well, it's nice outside. If you can help us clear out all the cans and stuff, yeah, and hopefully see you all next month. Oh, and again, I'd like to thank our sponsors, Skyscanner, Informatics Ventures, and Cultivate. Yeah.